Adonis's Object Relational Mapping, or ORM Lucid, comes with two primary ways that we can communicate with our database: models and its database module. In the last two lessons, we spent time learning how to set up and define our models. In this lesson, we're going to step through the basics of CRUD operations, which are creating, reading, updating, and deleting, using both the models that we defined in the last lesson and the database module itself. Then in the next few following lessons, we're going to step through each CRUD operation individually. So under the hood, both models and the database module make use of Connect.js's query builder to allow us to chain methods off of one another to ultimately build out our SQL statements. So here they have an example of a where statement where we initialize Connect.js against a particular table in our database. We chain off of that call a where statement saying essentially we want to only query where the first name is test and the last name is user. And then for those results, we only want to select the ID column. Connect.js will then take that statement, turn it into raw SQL, execute it against our database, and return back the results. So one of the two ways that we can communicate with our database is by using the database module. Using the database module, we have access to every table within our database. So this is going to be a great approach if you need to perform CRUD operations on a dynamic table. Maybe you have the table name stored in a variable and that variable value fluctuates. So using the database module, it looks a little bit like this line right here. So we're going to import our database module from Adonis Lucid database. We're going to call a from method and pass in the table that we want to execute our SQL against. And then from here, we really have access to pretty much any of Connect.js's query builder statements, right? So we can connect a where statement saying we only want tasks where the status ID is idle, and we want to select all columns from that table. This select statement in particular is using a wildcard. This is default, so we could leave this select statement off entirely. However, conversely, we could pass in a single column name here instead of the star, or an array of column names to select particular columns. And then just like our Connect.js example, this is ultimately going to be built into a SQL statement, which will look something like this. So select star, select all columns from the tasks table where status ID equals 1, and the status enum for idle value is 1. The second way that we can communicate with our database is via models. Now, unlike the database module, models are restricted to working with the specific table the model represents. To start off with a basic example here, for our task model, we import our task model from app models task. We initiate the query builder by calling the query method. And from here, we pretty much have access to Connect.js's query builder statements. So database from and then task.query result in almost an identical query chain available to us here. The main difference between the two is that with our database module, the where statements, or anytime that we're referencing a particular column, so whether that be in select statements or any other method, we need to reference the column name as it's defined within the database. For our model approach, we can reference the column name either as it's defined within our model or as it's defined within our database. So status capital ID is valid here, or we could also do status underscore ID here as well. Both of these approaches would work just fine. In addition to that, if we were to go into our task and give this a manual column name definition for the column decorator, so column name equals status underscore ID, we could change now this property name within our model for status ID to whatever. So it could be something like current status rep. And then we could then take that and we could also use that within our where statement as well. So now status capital ID is no longer valid because it's not defined within our model. We would then be able to use either current status rep or status underscore ID. Let's go ahead and undo that really quick. Okay, so now before we can read, update, or delete, we must first have some data. So let's start by learning how to save some data to our database. Now to do this, let's use the most simplistic model that we have available to us so far, and that's our project. So within our project, in order to create a new project, we really only need to provide one column value, and that's the name. Our status ID has a database default of 1. Our created at and updated at are going to have a database default as well, and then Lucid will also auto-create and auto-update these for us as we define within our datetime decorators. Our ID is also going to be dynamically created within the database as well. So that leaves us with just needing to define the name as the minimum viable record. Okay, so let's go ahead and jump into our project's controller here. And within our store statement here, let's go ahead and create a record for our project. So for each of these different CRUD operations, we're going to go through the model approach first, and then we're going to circle back and cover the database approach second. So to start off with, we're going to want to import our project. We're going to do that automatically using Visual Studio Code's autocomplete. So const project equals new project, and then tab to auto import that from the IntelliSense autocompletion from app models project. And then we call that as a constructor method. So essentially what we're doing here is we're creating a new instance of our project model. And then from here, all that we need to do is set the properties that we want the record to have. So if we just did name here, we could do model example1 And then to save this record to the database, we could do await project.save. And now it will save to the database. However, in most cases here, you're not going to want this value here to be a hard-coded string. You're going to want it to come from the request itself. So maybe we're submitting a form or we're sending a post request via a REST client. We're going to want this to come from the request itself. So let's go ahead and import our request and response so that we can grab our data and then respond accordingly. So to grab our data here, all that we need to do is const data equals request. And then there's a method here called only. This will allow us to only grab particular values from our request object. As you can see in this example that pops up within this tooltip, we can provide it an array of keys that we want to grab off of the request, and then it will leave anything else off of our data object that we do not define. So here we're just going to want to grab name, and that would be it. So this is a great approach if you have multiple columns that you needed to grab. So if we also wanted to provide the status ID here, we could include the status ID here as well. However, if you only need to grab one column as we are here, you could do an alternative method here, so we can grab the name directly by doing request.input and then pass in the name of the property that we want to grab off of our post request. So now we have direct access to our name, and we can now provide that directly into our project.name value. So we can go ahead and save that. I'm going to go ahead and get rid of our data example here. And then to respond to this, let's just return response.json, our newly created project. Now, an even easier approach that we could do to create a project here, if I comment this one out, we could do const project equals await project.create, and then we just pass in an object of the project record that we actually want to create. So here we would just pass in name. And by doing just a single property here for the key and value, this is identical to just doing name. I'm just leaving it off and defining it all in one go. So we can go ahead and save that. Let's go ahead and jump into our routes. And let's just define a resource so that we have all of our project routes defined in one go. So route.resource, projects, define this for the projects controller, and we should now be good to go. Let's jump into our terminal, make sure that we have our project running, and then we can jump into a REST client to test this out. So I'm using Insomnia here, so I'm just going to go ahead and create a new request. We'll call this for post, and for the body, let's do a JSON body. For the URL here, we're going to want http://localhost 3333/projects. And then for our JSON body here, we're going to want just a name value. So we'll do model example 1, the exact same as the hard-coded string that we had within our project controller. All right, let's go ahead and execute that statement. And there we go, we get back the newly created project from our database. We can easily confirm that this worked by jumping into a database GUI. I'm using Tables Plus here. So let's refresh our projects table, and we can see we now have our record for model example 1. And it was given a default status ID of 1 here. Okay, and then let's quickly cover the database module approach to creating a record. So for this approach, what we would want to do is import the database module. So const project equals await database. Let's tab to auto import that from Adonis Lucid database. And so here, unlike with the default query builder, we need to initiate an insert query builder. And the way that we can go about this is by calling off of our database module a method called insert query. And then from here, we need to define the table that we want to run this insert query against. And we could do that using the table method. So for our normal query builder for our database module, we'll typically use from whenever we're querying from, updating, or deleting using the database module. Whenever we're inserting, we need to use insert query and table. And then here, table accepts the exact same as from, so we could just pass in our table's name. And then lastly, we need to call insert so that we can define the actual values to insert within the database. So here it would just be name. Okay, so a couple of things to note here. First and foremost, we could, instead of defining a hard-coded string for our table here, if we know the table that we need to run this against, we could import our model, and off our model is a property called table. And this is the exact same representation. It represents the table for the model. I'm just going to leave this as a hard-coded string. Second, your capabilities for returning from this insert statement vary based off of the database type that you're using. So I'm using MySQL. So no matter how I define this insert statement, I'm always going to get back an array of the inserted value IDs. However, if you're using something like Postgres, you're able to define how you want this to return because Postgres supports returning values. So if you're using Postgres and you want to return back the newly inserted record, after our insert query here, before we actually call the method here, we can define a type for this insert query by doing an open bracket, the model name that we want to return back to, or any really generic type, and then our end bracket. And now this insert query, whenever it executes, will return back to us our project that was newly created in the database. So I'll leave this here. Let's go ahead and execute this using Insomnia, and we'll see I'm using MySQL, so I'm just going to get back an array of a single newly created ID. So let's go ahead and execute this. I should have changed that to 2, but that's okay. And you'll see I got back an array of the newly created ID of 2. Okay, so that's a quick overview of inserting within our database. We're going to go more in depth with this in the next lesson. Let's go ahead and move on to querying from our database. So we're going to use our index method here for our multi-record queries. For our single record queries, we're going to use show. So for index here, we're going to define our multi-insert queries. We're going to start off with our models, and we have several different options available to us. So let's start off with const projects equals await project. And then just like the initial example I showed within our tasks controller here, all that we need to do to instantiate a query builder is call the query method. And now we have access to Connect.js's query builder. So from here, we can define where, so we could define which records we particularly want to grab. Okay, so here we can do status ID and pass this in a status of idle. And we can leave it just like that. Let's go ahead and import our response from our HTTP context contract and return response.json our projects. Let's go ahead and save that, jump back into Insomnia, change our HTTP method from post to get, and then we can leave it as just /projects. Let's go ahead and send that off, and we should get 2 records back. Yeah. So projects, we have an ID of 1 and 2. Both of these have a status ID of 1, which is idle. If we were to jump into our database here, refresh to get the second newly created record, change that to a status ID of 2, and reinitiate that query, you'll see we get back just the single response for our status ID of 1. Now, using this method to query a single record, all that we need to do is chain a single method off of this. So let's go ahead and copy and paste this down into our show method. And let's import response from our HTTP context contract. And then all that we need to do to get back just a single record from this is tack on to the end of this a chain of first. And what it will do is it will return back just the first record that matches this query. Now the show route comes with a route param of ID. So let's go ahead and also import our params from our HTTP context contract. And instead of doing a where statement on our status ID, let's just change this to ID since that's our param value, and then pass in params.id. So now we're going to get the first record that matches the ID that we pass within our route parameter value. Let's jump back into Insomnia and let's tack an ID onto the end of our projects. So let's do 2 here, and let's send this just so we get a different record within our database that was showing them prior. And you'll see we get back the project with the ID of 2. If we change this to 1, we'll get back the record with an ID of 1. And if we change this to 3, we're going to get back null because no records have an ID of 3. Now there's an alternative method to first that we could call, called first or fail. And so what this will do is it will attempt to find the first record that matches our query. If it doesn't, it's going to error out the request. So this is great for instances where, we need to have a project in order to move on, which is probably your typical use case. So let's jump back into Insomnia here. Let's try to rerun this project for 3. Instead of getting null, we'll get back an error this time. And you'll see we got 404 not found. And since we're in development here, we get back a nice developer-friendly error response to us. Okay, and then let's quickly go over another way that we can query using the model approach. So let's comment this out here. And what we can do is const projects equals await project. And now instead of initiating a new instance of a query builder, what we can do is call a particular method called find many. And what this accepts is an array of IDs. So we could do 1, 2. And what we should expect back are 2 records with both the ID of 1 and 2. So we can go ahead and save this and jump back into Insomnia. Let's change this back to just /projects, send this off, and you'll see that's exactly what we get back. Okay, so this is another approach that we have available to us to query multiple records using the model approach. For the singular approach here, let's jump back down to our show. Let's go ahead and comment this one out, and let's do const project equals await project.find, and this accepts a single ID value to find. So we can do params.id here. And this will find the record for the ID that we pass into our route parameter. And just like with this first or fail on our project query builder here, we also have available to us find or fail. So it will attempt to find the record with the ID that we pass in here. If it doesn't find it, it's going to fail out the request. Alternatively, if we comment this out, we could do const project equals await project.find by, And then this essentially just accepts a where statement. So we only want status ID of status.idle for this. So what this will do is it will find the first record with a status ID of idle and return that back to us. Now, just like with our prior two examples here, we also have available to us find by or fail. So if it fails to find any records with a status ID of idle, which is 1, then it's going to fail out the request. Again, if we just do find by, if it can't find it, it will return back null. If we do find by or fail, it will return back that 404 error. This particular find by doesn't really make sense for a show statement. Find or fail here makes more sense. Find by or fail will be great if you're using something like a slug, a string unique identifier for a particular record. Find or fail is great if you're using an actual ID for your route parameter. And since we're using a resource, it defaults to using an ID for that route parameter value. And just remember, you can hop into your terminal at any time and run node ace list routes to get a list of the routes defined within your project. So if we scroll up slightly here for our projects controller show statement, we have projects/ID. So here, find or fail will definitely be the preferred approach. Okay, so that should be a good overview for our model approach. Let's quickly cover our database approach. So let's go ahead and comment that out, and let's insert some spaces here. Const project equals await database, and then just like our query, we want to do from our table name. So let's do projects. And from here, it's basically going to be identical to our project model query builder approach. So we're going to do .where ID is params.id. And then since we only want a single record, we're going to want to either do first or fail, depending on whether or not you want the request to fail out if it cannot find a record value. So we can go ahead and save this, jump back into Insomnia, and let's give it a go. So projects/an ID that exists within our database, and we get back that single ID value. We can change this to 2, send it off, we get back the record of 2, and we can send it as 3, and you'll see we get back a 404 error because the record with an ID of 3 does not exist. So that should be a good quick overview for querying data from our database. We're going to go over this in more detail 2 lessons from now. Let's now go ahead and move on to updating data. So down here within our update method, let's first cover our model approach. So in order to first update a record using the model approach, we first must have an instance of a record. So we're going to need to query the record itself. So we're going to do const project equals await project.find. And since we need a record in order to update a record, we want find or fail. And then we could just do params.id. We're going to want to import both our response and our params. So response, params, and I guess our request here as well, so that we can grab some data to actually update our record with. And now that we have our record instance, all that we need to do is, just like with our create statement here, we just need to update the actual values that we want to update. So here we could do project.name equals request.input name. And now this will overwrite our existing name with whatever we pass in with our put request. And ideally here, whenever you're creating or updating records, you're going to want to also validate this data. And we're going to go over that later. Just know that right now we're passing data directly into our database. And typically that's not ideal. We want to verify that this is actually data that we want to persist using a validation step. Okay, so lastly, all that we need to do is persist this change to our database. And just like with creating, all we need to do is await project.save. And then lastly, let's return response.json, our new project. So let's go ahead and save that, jump back into Insomnia. And instead of doing a get, we're going to want to do a put or a patch. And then all that we're going to want to do is change the name up here. So we're going to change it from model example 1 to model example 2. Let's change our ID from 3 to 2 here and send it off. And you'll see back, now we get back our project with an ID of 2, and our model example is now the proper 2 instead of model example 1. We could change this again if we wanted to. We could do --edit, send it off, and you'll see we get that back as well. We can confirm that that's actually saving by jumping into Tables Plus, refreshing, and you'll see we get edit. Okay, so let's say for this example that we have multiple properties that we want to update within our project. So let's do const data equals request only. And we have a name, and we also have an optional description here. So what this will return into our data here is an object of both name and description. So here we're still going to want to find our project so that we have an instance of our project record. And instead of calling project.name, instead of setting, project.description and yada, 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 on and on and on for all of the properties that we have within our project, we can simply do project.merge. And what this will do is it will merge our data object with the existing project properties. So if we pass our data in here, what it will do is it will change the name and the description and leave everything else alone. And then we still want to await.project.save to save that to the database. So we can go ahead and save this. Let's jump back into Insomnia. Let's add a description to our put request. So description, test description, and let's send this off. And you'll see that we get back a project with an ID of 2, model example 2 edited, which I didn't change at all, but we could have. So here we'll do edited 2, send it off, and you'll see we get back edit 2 with our description. Our status ID remain the same, our created at remain the same, and our updated at updated because we have that set to auto update within our model itself. Okay, so let's quickly go over the query builder approach for this. So let's comment this out and let's do const project equals await database dot from projects dot where, and this is going to be identical to our show up here since we just want the single record based off of the ID that's within our route parameter. So we're going to do where ID is params.id. And now instead of just grabbing an instance of that record, we can directly update the record off of the query builder itself by calling dot update. And then here we just pass in the values that we want to update. And this essentially acts the same as this merge right here. So we could pass in just the name if we wanted to, or we could pass in our data object itself. So we can go ahead and save this. Let's jump back into Insomnia. Let's change these up. So edit 3, test description 2, send this off. And you'll see that instead of getting back the record itself, all that we get back are the number of records that were changed. And since we're doing a where statement on an ID, we should expect that to only be 1. Okay, so that should be a good overview of updating. Let's go ahead and move on to deleting. So within our destroy method here, let's again first cover the model approach here. And just like with updating, we're going to need an instance of our record. So we're going to want to do const project equals await project.find or fail params.id, because again, the destroy route here has a route URL parameter of ID. So we're just going to pass in the ID that we want to destroy. This will be available to us via params. So we're going to want response so that we can return back and our params from our HTTP context contract. And then in order to delete here, all that we need to do is call await project.delete. And this will delete out the record from our database. There's no need to call save here. This will automatically just take care of it for us. And then as verification, we can return response.json, the project record that we just deleted. Let's jump back into Insomnia here, change our method from put to delete, and then we can leave it as projects2. This should delete out our projects2. Our JSON body, we can do no body there since we don't need to send anything up with this request, and send this off. And here you'll see that we get back the record that we just deleted out of our database. We can confirm that it deleted by jumping back into tables plus, refreshing, and it's no longer there. Okay, last let's cover the database module approach for this. So let's comment this out. And what we're going to need to do here is const project equals await database dot from projects dot where. So this is going to be identical to the last two examples here. ID is params.id, and then instead of update, we just call delete. And then we can save that, jump back into Insomnia. We no longer have a record for 2, so let's call 1. Send that off, and we get back, again, just like update, the number of records that were altered, which is just 1. We can jump back into tables plus here, confirm that that was indeed deleted, and it was. So we're good to go there. So now we no longer have any records. We've covered a simple approach to CRUD using both the model approach and the database module approach. In the next few lessons, we're going to dive into these in more depth. We're going to cover deeper query statements. We're going to cover relationships and all of that fun stuff.